Okay, so my name is Edvin Mako, and together with my colleague Nemčík, supervised by Tibor Krajčovič, we managed to create a project called Smart Indoor Greenhouse, which by the motivation that the need that the plants and the environment of growing fresh and bio vegetables anytime and in any environment can be very challenging in those times, and we wanted to easy the life for the users or the anyone who wants to grow plants inside their homes. By this motivation, we wanted to create a smart greenhouse by the use of technology and smart IoT hardware to monitor the environment and grow bio plants. Basically, our greenhouse consisted of several parts. For the first part, we used several hardware components, and the first part was consisted of the MQTT broker, which was connected on the ASP rover, which was connected to and communicating with the server using MQTT protocol, and was used to set up the environment, the ideal environment for the growing plants. Like it was used for managing the temperature, the quality, the water pump, etc. And the second part, we also used an ASP module, which was communicating with the server, and it was used for transmitting the data collected from the greenhouse sensors to the server. The third part was basically, this is the architecture. This was the whole greenhouse architecture, which consisted of several sensors. The monitoring sensors, like we see here, for the moisture, the water pump level because we had a water pump here to be able to water the plants when the moisture was low, for example. We also had a servo, which opened the trap for our greenhouse, and also a ventilator which regulated the air quality if the air was too and also we used an air quality monitoring sensor with a light sensor and multiplexer connected with the ASP rover, and basically this was the hardware of the greenhouse. This is we can see the electrical schema, which we managed to draw the final electric schema. And the third part of our greenhouse consisted of a web interface, basically, which was the central point where the data from the greenhouse could be seen. Like we can see the live real-time temperature, real-time humidity, water level, and air quality. And also we can create, based on what plants are we growing, we can create a separate plan depending on the plants we are growing. And based on this, some algorithms were used to open the trap or to water the plants when needed. This was basically we used Influx for real-time monitoring of data, and we also used Influx to send the signals to the sensor to open the trap or to start cooling the air, or basically this was the central point of data monitoring. Here we also use 3 moisture sensors, when we can see that, for example, at the first they were not very calibrated, but after that we can see that when we basically opened the water here and the sensors were low, and then when the moisture was drier, then those values were higher. Here you can see also a live prototype as it looks. Our greenhouse, we managed to, like, after 8 days, we managed to grow chili plants, basically. And the greenhouse was working 8 hours straight, where the watering was done automatically. We also monitored the data from the sensors. Here is another picture of the hardware, and basically this is what we managed to create. We also want to do, as a future work, we would like to add a heating system, and we would like to add some artificial intelligence, machine learning, or some algorithms which will adapt automatically based on the data coming from the sensors. Yeah, and our solution is basically scalable because everything runs in Dockerized environment, and yeah, so this was.
Okay, thank you very much. Questions?
How do you characterize the quality of air?
Actually, we have an air quality sensor there, but yeah.
Is it, I don't know, the level of oxygen or?
Yeah, exactly, the level of oxygen. But after we actually implemented it and measured the values, we realized that the sensor isn't that like the correct, it's not like getting as the correct values. So then we just actually we leave it there for just only for purpose. We realized that we actually the data we are getting from the sensor aren't that the correct. So yeah, that's like yeah.
Right, it's for future work then.
Yeah, definitely. Actually, this project definitely needs a lot of work to be done in the future. So this is.
But anyhow, you did a great job. You made the hardware. You made a kind of a model, physical model, so you can now experiment.
Yeah.
So another question is, what kind of algorithms did you try? So did you do anything with the data, some processing of it?
Actually, you mean how we like were able to how we knew when to water,
when to open, when to close yours?
Yeah, as Edvin presented, we have this web interface where you were able like to put how you want the plants to grow. So since we were like planting chilies, we found like some materials on the internet that about the values chili needs to plant. And actually, if you put it here in the web interface, there is like temperature, fields, humidity, and moisture. So after you put the values into the system, then when since we have influx there, and the data are gathered, I think every 5 or 10 seconds, not sure anymore, but I think like in periodically in small timestamps, we were able to like we set up the influx the way that if any value is like outside of these of the values we put into the web interface, then we got like an information from the influx, say, okay,
right, okay,
something is out of,
so it's kind of a threshold.
Yes.
Algorithm, yes. Okay, thank you for your answers.
Yeah, you're welcome.
And take care going back home. Have a safe
Thank
trip.
you very much.
Yeah, okay.
Thank you, Andre.
Okay, thank you. You said that you plan to use machine learning algorithms, and it's very popular to put it everywhere. So do you have some idea how to use it? Because you need to have some data to learn some algorithms on, and for what purpose you basically plan to use it in your application? Thank you.
Sorry, can you repeat please the first part of the question, because I didn't understand it?
Okay, so you said that you plan to use machine learning algorithms in your system.
Yeah.
And I wonder if you have some idea how to apply it to your case, to your situation, to your system.
Yeah,
So can you
basically,
explain it a little bit more? I know that it's future work, but I wonder how to apply machine learning algorithm to the system. Thank you.
I think at first it will be like collecting of the data, or maybe finding a data set for ideal plant growing. For example, I don't know, we had a data set with plants where some kind of sensor data were gathered. We could use that, but if not, then we would had to gather the data for specific plants ourselves, and then try training the models on it and constantly improve. I'm not sure now if some data is available for plants and for growing plants in ideal environment, but that would be like the targets to have enough data and to like deploy some machine learning model which would automatically then adapt based on what the users are growing in their greenhouse.
Okay, thank you. Good luck.
Thank you.